In this video, I want to talk to you about the levels and scales of measurement, why they're important, and how we use them within our scientific research. So there are 4 different levels or scales of measurement. The first one is nominal, and nominal does not have an evaluative distinction. So this means that one value isn't necessarily greater than another value. So an example of this is citizenship. If you are looking at a group of people and you look at their citizenship, being from the UK versus being from the US, one is not greater than the other. It's just a categorical data point that you would gather. Now, these 4 levels or scales of measurement basically increase as we go down. So the lowest level is nominal. The next level is ordinal. And so ordinal means that one value is greater or larger than another value. Essentially, there's actually an evaluative distinction between being a 0 versus being a 1. And so an example of this is rating scales from 1 to 10. So if I say rate your pain from 1 to 10, if you say you're a 9, that means you're having greater pain than someone who says that they're a 5, at least relative to them. And so this means that there is actual meaning between the different numbers assigned versus citizenship. It's probably just a key. If you are assigning numbers there, it's probably just a key. Being a 3 doesn't mean you're 2 better than 1. The next one is interval. So interval is ordinal, which means one value is greater or larger than another value, but it also has equal distance between values. So for example, if you have temperature in Fahrenheit or Celsius, you would have interval data. The difference between 96 degrees and 97 degrees is the same amount of difference between 34 degrees and 35 degrees. Basically, each of those measurements are Basically, the distances between those measurements are the same. And then you have ratio. And so the difference between ratio is it's basically an interval scale plus having an absolute 0 point. And so an example of this is temperature in Kelvin. Fahrenheit and Celsius have negative numbers. Kelvin does not. 0 actually means something and you can't go negative. This also might be something like an absolute weight. You can't have negative weight. You can't have negative mass. You can have a difference between 2 weights, but not an actual negative weight. And so these are all things where an absolute 0 actually means something. Now let's talk about in practice, because it's nice to know these 4 levels of measurement, but in practice, do we really sit there debating whether something is interval or ratio? No. So in practice, we have 2 main categories. We have categorical and continuous data. And so our categorical data are our categories or our groups. And this is typically our nominal and our ordinal data. And so this would be like asking someone, what's your favorite color? So if you had blue, red, purple, green, yellow, you have 1 through 5. Picking yellow versus picking blue doesn't mean that it's higher. And even if you had a rating scale, it's still categorical. So there's distinct categories that everyone falls into. And it's not that all of these that these numbers are specifically as numbers. They're more as keying for categorical data. Something like phases of matter, gas, liquid, solid. If you had keys for those as 0, 1, and 2, it's still categorical data. You can't have a 1.5 and things like that. Whereas continuous data means that you can have any value within the given range. And so there isn't categories along there. It's just there's any value within this given range. And these are mainly your interval and your ratio scales of measurement. And so this would be things like temperature, mass, or length would all be continuous data. And it's really important to know whether you're working with categorical data or continuous data. And then as we dive in deeper, it can be important for very specific things, whether you're working with the specific type of data you're working with. And this determines a lot of things that we do with this type of data. How do we use the knowledge of the scale of measurement we collected? So the first is for statistical tests. If you have something like nominal or ordinal data, you're typically going to use something like a chi-squared. You need to be able to look at the interdependence between categories, and that's the type of statistical test you would use for that. If you have more interval data or ratio data, you're going to use something like t-test or ANOVA to determine the differences between 2 groups. For things like data visualizations, nominal data, you tend to use bar or pie charts, at least bar graphs where at least one one axis is nominal data. Versus if you have continuous data or intervals or ratios, you're going to use something like scatter plots or line graphs. In overall mathematics, the type of data we collect controls how we can use those numbers we generate. When you're dealing with nominal or ordinal, you might be able to get a median. So this more makes sense for ordinal data. If you say, what is the median rating in a pain scale? That makes sense. For nominal data, it really doesn't even make sense to get a median. And then adding and subtracting doesn't tend to provide meaningful analysis. Versus in interval or ratios, you allow for mathematical operations to occur. You can calculate actual means, and those means actually mean something. With ratios, multiplication and division makes a lot more sense, whereas interval, because there's no absolute 0 point, multiplications and divisions might not make as much sense as adding and subtracting. So overall, these are the different ways that you can use these levels or scales of measurement, and it's important to know what you're collecting and to make sure that you are collecting the right level of measurement for what you plan to do in the study. If you want to run a t-test or an ANOVA, you want to make sure you're not collecting nominal data to run that t-test or ANOVA. If you want early ad-free access to the YouTube videos and to be able to download these slides, I recommend you check out my Research Mastery Academy. It includes all of my research content, including my courses on research design, data analysis, and research writing, even a specific dissertation course as well. I will leave a link below if you're interested in that, and I hope this video was helpful, and I look forward to seeing you in the next one.